I made this Minecraft shader using Blender, and today I'm going to show you how to create it from the ground up. We'll start with a simple world and build the shaders step by step, adding everything we need to make it look as close to Minecraft as possible. It might not look 100% identical right away, but by the end, you'll see just how close we can get. So, let's dive right in and start building the shader. Also, this tutorial is going to be broken down into 8 main stages, so take your time, follow along step by step, and by the end of it, you'll have this incredible setup fully working. Try creating a new Minecraft world, or use the old one. This doesn't matter. Do some activities in this world. Try building a house in a cave or outside. It doesn't matter. To export 3D worlds, we must use Mineways. Mineways is a free, open-source software that allows users to export specific sections of Minecraft Java Edition worlds into 3D files. After downloading it, click File. Choose any world you want. And now, you just need to select the area you want to export and adjust the data at the top. Click Export for rendering. Choose a path location to save your 3D world and name it anything you want. You can call it a cow, a 3D world, an amazing world, the amazing and strange world of Gumball, just world, or an egg. It doesn't matter. Finish everything by clicking OK. Then wait a minute for the world to be saved. Change both the render and viewport samples to a lower value color management view transform to standard to get accurate colors. Press Ctrl+A and delete everything. Load your saved world from a specific file. Well, this is my world. Select Stone and press Ctrl+J to join them into a single object. Change FPS to 60. Change frame synchronization to frame dropping, and set your animation length in the output properties of the scene tab. The world looks a bit gross because it seems to be made of a single material. Change the viewport shading from material to texture so it displays the images. The mapping for linear images needs to be converted to closest to eliminate the mapping. This can be done hardly by going to each material, around 140 materials, and changing the type from linear to closest. Since this takes a long time, I wrote a Python script to make it easier. Press Ctrl+A to select the full code, then click the play icon on the right to run the code. The images of the world are now clear and pixelated, just as we wanted. If you go to render, you will find the world illuminated thanks to Emission, because it is good and responsible for disabling the shaders we don't want. Now, I will create a new space responsible for managing the nodes. I will make just a few adjustments to make it clear to you, and I want it to be clear and good enough to take care of the nodes. Change the global perspective so you can see the world correctly. The world seems a bit cluttered and looks complex, and that's good so that I can make it look easy for you to show you that this method works with all worlds. After going to render, we will switch from object mode to edit mode. If we select any face, we can trace the path of its material, and this way we have the ability to easily edit the material without having to go to the materials menu. Press M and choose by distance to delete any gaps that might ruin the setup. Name this workspace Nodes because it is responsible for managing all of these nodes. Press Shift+A to add a bump node and connect the output to the emission strength input. Press Ctrl+G to create a node group. Press N to open the sidebar and delete all unnecessary inputs. Press Tab and name this Default Shader. We will now use another Python file so we don't waste time and solve problems automatically. Since the world contains a large number of materials, around 140 materials, the code will work to link the default shader node group with the rest of the emission strength values of the materials. Click Open and select nodelinker.py, or write it yourself right on the screen as you see it now. I am ready for it. I will correct a small mistake here. Okay, things are looking good right now. Now let's run the code by clicking the Run button. Let's check if the code worked. To verify, check if every material now has the default shader connected to its emission strength. And right now, we see that the world is exposed to a fake light in a specific direction, exactly like Minecraft does to the world. Wait, there is something strange going on in the world. What do you notice? To fix that, we first need to click Clear Geometry Data, located under Object Data or Geometry Data. Click Flat Shader with the left mouse button. Let's go back again. And now we need something important. We need to separate the colors. Add Separate Color. Add a Mix Color node and connect G, green, and B, blue to it in this way. Set the type to Lighten. Now, we are getting a bit closer to Minecraft's lighting, and now we need to use the red color. Alright, to do that, duplicate the Mix Color node with the Lighten type. Now connect the red color and change the value to 0.3. To get rid of the black color, duplicate it again. Well, the world looks good and nicely lit, but it looks a bit like sunset time because the color we used to eliminate the black is a bit closer to gray. To solve this problem, we have to change the mix color type from lighten to mix only and make the other color completely white. Don't forget to invert the bump effect here. Now I am going to do some fixes. Select all of these and press Ctrl+J to put them in one frame. Alright guys, I've separated the nodes responsible for the Minecraft morning lighting in order to create an attribute responsible for selecting the faces that don't get exposed to light. Now, let's put in some things. Add an RGB color node and connect it to another input of the result node. We will put this temporarily so that we can shade the faces that are not exposed to light. Create a new attribute. Try to clean up your nodes regularly. Add a mix color node and keep every connection from the attribute output plugged into the factor input of the mix color node. And name its output Shadow. Alright, let's now go to Geometry Nodes. Click on the New Geometry Nodes button. Add a Raycast node. Then place a Store Named Attribute node. Connect the geometry output to the Raycast geometry input and connect hit to value. Change the domain to face and name it Shadow. You will notice some black and strangely dark faces appearing. And you will notice that the light is supposed to point downwards, but it's pointing somewhere completely different. It's pointing along the x-axis, which is wrong and needs to be fixed. And this makes the mesh feel distorted and quite strange, in addition to having dark faces for no reason, even when exposed to light. For example, like this area here. To fix this, we need to place a position node and a normal node as well. Add a vector math node. Connect these two together. Connect the output to the raycast source position input here. And you will now notice the disappearance of the dark areas, thanks specifically to the normal node. Well, this was supposed to be solved easily. But if you notice in the settings of this shape or object, you will see that the world is flipped by 90 degrees on the x-axis, and this is what made the light direction wrong. Therefore, this needs to be fixed inside geometry nodes. Add a combine XYZ node, and in order to control the direction of the ray casting projection. Therefore, we will add a vector math node and set its type to normalize in order to get rid of rays that are not aligned with the light direction. Well, temporarily set the values to -1 so you can understand the situation. Now the lighting is heading to the right, and it was supposed to go from top to bottom. Well, as you can see now, before fixing anything else, we need to adjust and organize the nodes in geometry nodes. Now we will organize the spread of the normal rays on each face, and to do that, we control the size of this ray using a vector math node set to scale. Set any value here that is suitable for your world right now, and make the ray length very large, about 1000. Set the combine XYZ values like this, a value of 2 for the y-axis. Well, we got the shadows we wanted, but they are strangely too sharp. Now we need to get rid of this. As you can see here, I'm playing around to spot any errors or discover anything a bit concerning. Well, let's go back to solving the problem we want to fix, which is the shadow sharpness. Increase the raycast there. Directly after is hit, add a blur attribute node. We are starting to get a bit of that Minecraft shadow look, which is good. Now, tweak the values however you like. Now, place a map range node so we can control the light intensity and shadow presence. Adjust the values however you like until you get the look you want for Minecraft. Or copy these values here. Don't forget to always organize your nodes after every task you do. Well, that's what I'm doing right now, just organizing. Well, anyway, select all of these now and press Ctrl+J so you can enclose them all in a single frame. And I will repeat this process until I make these nodes easy for everyone to read. If you encounter any weirdness or any harsh cutoff in the pitch black, adjust it right here just like I am doing. Alright, let's head back to the shader nodes now and bring back the natural Minecraft lighting. We are going to replace the RGB with the node we created earlier. Well, we are starting to get the real Minecraft shader look now. It looks like everything is pretty much okay for now, and it's almost ready. Now we need to brighten up the world a bit. Add a hue saturation value node. Try playing around with the values of the hue saturation value node until you get the lighting you need. Well, you could say that you're now done with the lighting and shadows, and you can rely on this if you want, or if you have a little bit of experience to add new things and other stuff. If you think this is enough, you can stop here. Well, the world looks good, and the shadows are centering nicely as well, as you can also see right here. Alright, let's deal with image transparency now. Switch to Edit mode. Select one of the images, textures, or faces that need transparency, such as leaves or glass. Add a Mix Shader node, then connect it to your materials to get rid of those annoying black areas that appear in the textures and accurately control the transparency clarity. Connect the alpha output from the image to the factor of the Mix Shader node. Well, to fix the issue that just appeared, try swapping the materials here. Now we need to get rid of the back or side faces. To do that, let's add another Mix Shader node to finally fix the issue and have the transparency blend as required. And we also need a geometry node. Connect back facing to the factor of the Mix Shader. Also, we actually don't need this. Connect transparent to the second input of the Mix Shader. Swap the inputs again. Well, as you can see, we've done it. And this exact same logic will apply to all the faces that have images requiring transparency. Select the geometry node and press Ctrl-H to hide the unnecessary sockets. Okay, we will apply all of this to the rest. So I am currently organizing the nodes to avoid any issues in the future. Well, you might face problems with essential faces disappearing, which leads to holes in the glowing object like the lamp. Also, the reason might be that you accidentally pressed Shift+N, or that you didn't adjust the display data like alpha blend modes. It should be set to alpha clip. Also, don't forget to enable backface culling here. And if all solutions are exhausted, enable screen space global illumination, along with refraction and others as you see in the image. Also, always remember to check cycles as well if you encounter issues in EV, even though I suggest working in EV in this case. And also, if you find that the face doesn't need the back faces removed, you can use this node setup. Don't forget to always apply all these steps to everything in this world that requires transparency. Alright, now what I'm going to do is download the files that contain all the sky data we're going to use. I've split them up like this, and I tried to make it clearer for you. It's similar to a JSON file, and this is like a flowchart explaining what we are going to do now. Go to the nodes, change object to the world, go to render. Alright, we are now going to apply what we just saw. So we'll start by adding a gradient texture. Connect it. Then after that, you'll see pitch darkness. But look here, we now have a gradient in the world, but it's inverted and in black and white. And for that, press Ctrl+T, change the value here to 90 degrees. But first of all, make sure you have Node Wrangler enabled in the preferences. Go ahead and place a color ramp here after the shader node. We are going to use the previous flowchart so that we can get closer to the realistic look of the sky. Copy this color and place it on the right side of the color ramp. And in the same way, copy this one, but this time place it on the left side of the color ramp. Let me just reverse the direction here. Now I will head back to the flowchart. Copy this. Make this value control the left stop of the color ramp. Change this to ease. Arrange these by pressing G, Y, 0. Clear every space here. Select these, then press Ctrl+J to put them in a single frame. Now I will add a sphere type empty by pressing Shift+A. In order to control the sun's rotation, press S. then 10, so that it becomes more visible. Alright, I hope everything is clear to you so far. Name this empty sun performances or sun rotation if you want. Well, I think naming it sun config would be great. However, since we will use it for controlling the sun, we'll just call it sun preferences. That is more than enough. Well, I hope I spelled it correctly, exactly like this. I will scale up the empty a bit more. A size like this should be enough. Press Ctrl+A, then scale. Add a gradient texture, then a mix color. Copy this color. It is good. Put it here in the second slot of the mix color. All right, we need to place a color ramp so that we can reduce the sun's bloom brightness. We are copying a set of values that determine the positions of the color ramp's markers/stops. We will also copy the second value of the second marker here, then paste it here into the second marker of the color ramp. We always use ease. Press Ctrl+T. Replace the empty space here with the sun preferences object. Now I will change the mapping values until we get the shape we want. I think these values will do the trick. Alright, we will drag this back a bit. A value like this will do the trick. Alright, as you can see, when we rotate, move, or scale the shape, nothing happens. You need to connect the object input instead of the UV input. I will just reset the mapping again so that it matches the size of the controlling object. Set the Y rotation value to 90 degrees. Alright, it seems the diagram is starting to become almost useless now, so I will rely on my intuition here. My intuition says that we need to drag this value far back. Alright, everything is fine. The lighting is also fine. It seems everything is fine. Alright, when I rotate the shape, it rotates the sun with it, and this is good. Make the X value 90 degrees as an initial value. Now we will press Shift-A to create the cube responsible for the sun lighting. We will name it Sun, of course. We will scale its size up like this. Create a new material and name it Sun or anything else. Change the shader to Emission Shader. Set the value to 2G, then Y, then move it far enough. Press N, then go to View Settings. Just make sure to increase the end value well, greater than 9,000 meters. And in the same way, make the sun go back further and increase its size even more. For example, I think this value might suffice. Okay. Shift, click, and select the sun preference object. Then press Ctrl+P and choose Object Parent. Alright, I think we are done with the sky part. As for the clouds, I will show you how to create them later. Let's move on to the next part. Alright guys, I've placed my Minecraft character there. It's not that important. Alright, now I will select the top grass material. Add a hue saturation value node. Adjust the values slightly, like I am doing, to make it look more similar to Minecraft's dry badlands or snowy regions. Values like these will do the job. Alright, we'll select the side part of the grass so we can edit it. I actually prefer this angle near the edge of the world boundary because it'll be clearer and there won't be any issues with objects blocking the view. Now we are going to add a separate color node. We want to isolate the areas in the image where the green color is concentrated. And for this, we will use a color ramp so that we can isolate just the bright green color. Just like I am doing, try to isolate only the green areas. I think we are close enough. Now we are going to add another mixed color node. Plug the image into both inputs, but you'll find that one of them needs that hue saturation value node. Here we will copy the values from the previous hue saturation value node. Here I am just organizing the layout of these nodes to make them easier for us to read later. Alright, I think the grass needs to be just a little bit blue. Press Ctrl+G to group them into a single node group. Press Tab to exit the group. Name this group and remember it well. Alright, let's delete this too and replace it with the previous node group. I remember I named it Color Fixer. It seems that name isn't quite fitting, so I'll rename it again. I'll call it Grass Color Fixer. Adjust the values of the hue saturation value node. We want to make this grass a bit darker, slightly dark black, a little wet, and semi-frozen, and for that, I think these values will be very useful. Alright, I think we have finished this stage. I hope you liked the video, I hope you benefit from it the most, and let's move on to the next stage. And now I'll show you some details on how to create the clouds. First of all, create a plane. You have to do that, and then we'll create a new shader node setup. First, we need to create a material named cloud. And this is the shader node's layout that you need to follow. Inside it, place a default shader node connected to the first mix color input. And this is the color in the second input in hex. And then route the result or output to the emission strength input. And here is the color you need to set. Next, place another mix shader where the second input is connected to a transparent shader, and the first input holds the previous emission. As for the factor, it will be connected to the geometry data backfacing output. As for the geometry nodes, things are pretty simple as well. As for the geometry nodes, you will first create a grid mesh whose length and width are equal, exactly 250 meters. Also for X and Y, it's the same, 250. Then we will place a delete geometry node, set it to face, and have it delete all. For the result, we place a compare node set to the greater than type and set a value like 0.47 in order to delete random faces in the shape, using a noise texture so that it is the only node responsible for deleting faces randomly. Then we will place a transform node and change the scale of both X and Y to 10 while leaving Z as it is. After that, we place a set material node and select the previous cloud material. Then we place an extrude mesh node, set the value to 1.7 and deselect individual. We place a transform node and change only the scale Z value to -1. Then we place a flip faces node to recalculate the normals again. Next, we place a join geometry node and connect the previous input with the extrude mesh output. Then we place a merge by distance node to remove any unexpected gaps. We place a transform node and change the location Z value to 100 because clouds are naturally high up in the air. The geometry nodes plan ends here. All right, we are now in the final stage, and now we must first identify all the light sources in my world, but I only have a single light source. To select them all, we have to use a material, then click on Select All. Then press P and choose the first choose selection. Return to Object Mode. Return to the default shader. Remove this, add an attribute node, and name it Light. All right, now name this Lighted Objects. All right, now we have a few things we need to put into geometry nodes, so head over to the nodes. First, we'll place an Object Info node. Search for Lighted Objects here. Place a Geometry Proximity node here and connect its geometry to its geometry input. Place a Map Range node. Follow these steps and paste these values here. Place a Blur Attribute node. Set its value to 5, that's good, and connect it to the other node. Place a Store Named Attribute node. Connect its value to the result of the Blur Attribute node and set the domain to Face. If you go to the render view, you will notice that these illuminated objects are now lighting up the world around them, but in a fake, artificial, and clever way, and this is good without using real lights. Now, after heading over to the default shader, we're going to blend the lighting with the surrounding atmosphere. Place a Mix Color node and the Blend mode to lighten. Connect the outputs of both attributes to its two inputs. I think this computer lag is due to the video editor I'm using. Never mind, let's continue. Set the factor to 1, and now you can say that we have finished this stage as well. And you also notice that the world has become very similar to Minecraft. And this is a good thing. Look at how the light spreads here. Exactly like Minecraft. And with that, we've wrapped up all the steps. I truly hope you enjoyed the video and found this amazing result useful. Thank you so much for your continuous support and encouragement. Don't forget to subscribe to the channel and turn on notifications so you won't miss any new uploads. If you run into any problems or have questions, just leave them in the comments below, and I'll be happy to help. See you in the next video, and take care.